everybody, welcome. This Silent Disco talk is about fine-tuning open source models for agents, which is sort of one of the most exciting things I can think about talking about right now. It's definitely more than a lightning talk in terms of the amount of things that you could talk about. And I would say also not everything's known. I would say we're kind of very much in the early innings of what the best practices are for fine-tuning open source models for agents. But there are some things that you can definitely do. And so today I basically want to give you a brief overview of kind of why agents are exciting, what are agent systems, how do you might use fine-tuned open source models to build next generation agentic systems. My name is Tristan. I'm the co-founder of a startup called Continual.ai. We do some stuff that's related to this, but I'm not going to talk much about that today. So we're entering an era of AI agents. This is not me saying this. This is what I think everybody is saying in the hype cycle of AI right now. And AI agents can mean many different things. But to give you a few sort of concrete examples so that you can have them in your mind, this is GitHub Copilot that we're all familiar with. So this is, you could think of it as a conversational agent. And I would call it an agent because an agent responding in that sort of assistant-like metaphor with conversation, it has this sort of agentic workflow, although it's pretty simple. Typically it's you type something in, you get a response. Maybe you do a little bit of extra, like you give it some extra context. And maybe in terms of giving it the answer, it does a little bit of extra work. For instance, maybe it searches your code base, does a little bit of a lint check on the the fix or something like that, which could make it more in line with what you would think would be an agent. You can also have agents in other modalities, these agent experiences. So this is an example of an inline agent from a product called Hex. This is their Hex Magic. And here you're seeing something where they're inside of a notebook. You're typing something in, and you're getting SQL out or a diff of SQL out, and you can accept it. So it's very much similar, but it's more in line to the actual product experience. Again, a lot could be going on behind the scenes here, right? So this just could be as simple as sort of text to SQL diff, or it could actually go and look up your schema, take actions, and look things up if it was going to do a good job about that. A lot of times you really can't answer a question like text to SQL without having a lot of additional information or going into an existing system and collecting some additional information. You can become a little bit more, we're starting to see are in the early innings of even more ambitious agents. So here's what I would call like an event-driven agent. This is from a startup called Cleric.io. They're basically building an AI SRE, so site reliability engineer. It basically looks for events where your site's down or something goes wrong, you get an event, and then it tries to autonomously go and triage it. And so it goes and it looks through all of your systems, your Kubernetes clusters, and it generates these sort of full-on multi-step diagnostic triage investigations that then you can go into and examine. So there's a lot in this one. There's much more. First of all, it's happening in the background, and there's much more planning, multiple systems, multiple steps. It's getting quite complicated to think. It's not just obviously one LLM completion. It's much, much more than that. And finally, there's this vision of these autonomous agents. And here I'm using, this is a picture from GitHub Copilot Workspace, which is an upcoming GitHub Copilot product. But the basic vision is, hey, you should just be able to say, file a GitHub issue and have the whole bit of software be written for you. A plan being generated, the software being written, the software being tested, the software being UI tested, browser being loaded. All of that should just happen without any human interaction. So the question is, how do we build these types of agents? So the first observation that I want to make is just agents are, this talk is about fine-tuning models, and I'm going to get to that in the second half here. But agents really are systems. If you look at these examples, there's no model that is going to just one-shot do this, or this event-driven one. You need to go out into the world, take actions, collect information, investigate things, and that means that the model is operating within the context of a system. And so one way to think about a agent system is having sort of three layers. The first layer is the user experience. I would say we're still, and every one of these layers, we're still exploring what the best patterns are. So here we have these types of experiences that I just mentioned. And then you have the core agent system, the heart of the platform, if you will, which combines things that should be very familiar. Orchestration, so maybe think of something like LangChain, models, which is what I'm going to dive into, knowledge bases, which is think about vector stores, tools, which is think about APIs and functions, the ability to execute things, take action in the world, or collect information in the world, and then some sort of system that can monitor, fine-tune it, collect feedback, sort of the operational elements of it. And of course, there's the external environment that you're connecting with. Probably the best example of this is actually what we saw yesterday. So you can tell I just made this version of the slides. This is the slide that Apple actually gave from their Apple Intelligence system. And you can see it's basically got this, right? They've got the Copilot assistant experiences and agent experiences up top. They've got many models actually going on here. So these are on-device models over here, and each one of those vertical lines are actually a LoRa adapter on a foundation model. Just so you get a sense of scale here in terms of what a state-of-the-art agent system looks like. The on-device models are about 3 billion parameters, right? So they're very much in the domain that we can all deal with. Those vertical lines there are LoRa adapters on top of it. So they specialize many different adapters for different tasks like summarization, email responses, classification, action taking. Those are adapters on about a $3 billion base model. And then for some more advanced use cases, they go out to their cloud infrastructure stack. And the size of those models is not known, but it's on the order of GPT 3.5 or DBRX from last year. So it's actually not insane, right? It's definitely in the domain of open source. And then occasionally they go out into the ChatGPT and they say, hey, you want to go, they don't even picture it here, but they do have the ability to go out to an external model. So let's talk about models, because that's what really this talk is about. So the depressing reality is this slide, which is open source models are very much lagging right now when it comes to agentic or agent-based workflows. And so this is a benchmark called Agent Bench. There's a link in the bottom. And you can see this is as of last fall, so it's a little bit old. It doesn't have, for instance, Llama 3 here, which would probably do a little bit better. But you can look at the commercial API-based LLMs up at the top. You can see GPT-4 is quite high. We're missing a bunch of new models like Gemini and Claude Opus. But you can see there's a big gap between GPT-4 and the open source models that we have for these tasks. It does depend a little bit on the actual benchmark. So some simple benchmarks like the web shopping benchmark, which only has a few actions, all the models actually do well. Another sort of example of why it's a little bit depressing, but there's some hope in this slide. This is a benchmark for what's called software engineering benchmark, and this is the light version of it. It's showing a lot of different results for different coding agents. Basically, you have to have a GitHub issue and you have to solve it and have the test pass and something like that. And again, you can see, look at all of the top examples are using essentially GPT-4 Omni. And if you look at the bottom where you start to see some of the Llama-based models, now they're relatively small Llama-based models, you can see they're basically getting 0% of the cases resolved. Now, this is not it's not perfect because those are using very naive kind of RAG plus the model and that's it. But this also shows the importance of actually building agent systems, not just agent models or simple solutions. So putting an agentic kind of workflow on top of a model, even look at GPT-4 there almost at the bottom with GPT-4 plus RAG, and then you have Coder R, way up, higher. Now, still, I would say not a solved problem, right? You're only solving 28% of the test cases that they have, which are real GitHub issues that were, solved by humans. So not great. Okay, so what are the basic problems with models that we need to fix? There's basically threefold. And these are particularly acute for open source models. So the first one maybe to start with is knowledge. And unfortunately for many tasks, including for instance tasks like coding, you need to know a tremendous amount about the world. Like arguably you need to know all of the libraries in the world that you could potentially use. You need to be able to program in all the different languages that you need to be used. So you need to have a lot. And that can really only be solved by a very large model, or you need to very much make sure that you have an amazing sort of retrieval augmentation system that can really get all the knowledge that you need for the particular problem at hand. The second one is tool use or function calling. And unfortunately, a lot of open source models today say they support function calling. But if you go and try them, you'll quickly realize that they hallucinate a lot. They don't perform very well. And so if you're building an open source, if you want to do an agent based on an open source model, you're almost certainly going to have to fine tune it, which is what I'll talk about. And then the final one, which is I would say the biggest one that affects both open source models and closed source models is reasoning. And there's many ways to think about reasoning. I think actually the most important one from an agent perspective is the ability to like keep making progress in the face of errors and fix your errors. So a lot of people say, well, the problem with agents is that you have multiple function calls, you have a long path to, you have many steps in your plan that you have to execute. And if the tool use is only 80% accurate or 90% accurate, those errors compound. So there's two ways to fix that problem. One way to fix that problem is to make the tool use perfect, okay? And certainly we should make tool use function calling better. But that actually is always going to compound if that's all you do, right? So the longer the plan, it's always going to get worse and worse, and your success rate's going to go lower and lower. And we're not generally happy with like 90% solutions. The way to fix that is to make these errors anti-correlated, or to basically, if you get an error, you can see it, you can observe it, and you can fix it, right? And so where you can continue to plan, and even if you make very bad use of your tools, even if you only are 20% accurate, can you still make forward progress over time? Can you plan? Can you resolve your things? Can you learn from your mistakes? And I would say this is kind of an open question. So a lot of problems. Is there hope? So the answer is yes, there is hope. So this is an example of fine-tuning. This is an example that just came out about a couple weeks ago called Tiny Agent. And it's an example of an agent that is basically kind of a Siri-like agent that a team at Berkeley did, actually funded by Apple. And you can see the Tiny Agent models on the bottom. There are 1.1 billion parameter models and a 7 billion parameter model. They're very small models. That's because they're experimenting with wanting to run these models on device. And if you look at the success rate here for these models, you can see that actually it does remarkably well. So you get 85% accuracy for the tasks that they're doing. These are like sending an email, calendaring, things like that. Whereas GPT-4 Turbo is only getting around 79%. So you get, it's above GPT-4 Turbo with we're matching GPT-4 Turbo in this particular domain with a 1.1 billion parameter model. So in-domain agents, right, taking action with in-domain is absolutely feasible. So that gives us hope. The question is, okay, well, how do we go about doing this? And this is, an hour presentation that you could talk about. But I want to just hit on a few things which, you'll have to do, and then you'll have to dive really deep in it. And there's about 5 to 20 versions of every step that I'm about to go through. So the first thing that you need to decide, which some people just take for granted, is how you're going to call a function. So this is very small, but many of us are familiar with the OpenAI function calling API, which you have over there on the left. Basically, you define your tools using a JSON spec, and then you take action, you get a response back, which is basically the tool completion call, okay? Sounds like that's, you might think, oh, that's of course the only way this could work. That's not true. It's not, in fact, Tiny Agent does something slightly different. It actually, in this project called LLM Compiler, it actually generates multiple function calls on a go, references to the results, which are the colors there, and then it can pass those references into downstream function calls. So think of it as a DAG of function calls where you maybe have promises that you're pipelining into the next call, okay? And they are training a model to do this. And there's a lot of different approaches to this. You can also actually generate code, and inside the code you have LLM calls. There's a lot of different ways to call functions, not just this one-off function calling, or they also support parallel function calling with OpenAI. So first thing you need to do is decide on how you want to think about calling functions. The second thing you need to do is you need to generate data. Now the good news here is that, the bad news is that labeling function calling and generating function calling, particularly long traces of function calls, is really, really hard for humans to do. But self-instruct methods work quite well. So self-instruct methods are basically where you take the function. So this is an example from the OpenAI cookbook. They're basically 2 steps. The top part of that step is they're taking the function definition, and they're saying, hey, give us some plausible values for these entries. Like if you say get weather, it would say San Francisco, and the response would be 49 degrees or whatever it is. So it first fills out what a good function call could look like, absent any question. And then from that function call that it has, right, with all the parameters, it says, hey, generate some potential user questions. Pretend you're a user, generate some potential user questions that would generate this function call. So you're kind of working backwards. So work from the end and go back to a potential user question that would generate that answer. Okay? This is basically how all of the LLMs or coding LLMs are trained. Tons of LLMs are trained with this variations of this self-instruct pattern, where you're basically generating synthetic data for this, and it's often very much possible to do this. This can go quite far. So there's an interesting paper called Agent Gym, which does this, which is a gym environment for agents, which I'll let you read about to go deeper there. One other tip here is don't forget to cover the full scope of user behavior. It's not just about calling functions and knowing when to call functions. It's knowing, okay, you don't have the ability to call a function, it doesn't exist. The user doesn't want a function. The user wants a function, but the function doesn't exist. There are no functions and they want a function. So if you don't cover all of these other sort of permutations, these LLMs tend to hallucinate very badly. And this is a result from this paper called Agent Flan. The next thing you need to do is you need to choose a chat template. So the chat data that I showed you up front is actually not what the LLM gets trained on. The LLM gets trained on text, okay? So you need to map that structured data that you had to text. And again, you might think that there's only one way to do this, but there's actually many, many different ways to do this. And so two ways that are shown in this paper are, one is a React style template where you have a thought up front, like a planning thought, and then you say a tool call, which tool are you going to use? That's the second line up there. And then the third line is what parameters are you going to pass, okay? Now this particular paper says, hey, there's actually a better way to do this. This doesn't really align with conversational data that we've trained the large language model on. We can get better performance if we sort of decompose it, to kind of take it step by step and make it a pretend conversation. And so what's below you here is basically them saying, look, I can actually break this whole decision-making process up into a pretend conversation where I take things step by step, and I get better results if I do this. Behind the scenes, when you expose this as an API, this is all hidden. It still just looks like, let's say, the OpenAI function calling API. So a lot of room to experiment, generate, first how you're going to call functions, how you're going to generate functions calls, then how you're going to do the templates for function calling. Then you need to fine tune the model. And here I would say we're actually very, very early in terms of where the research is. When I was looking at all the different research papers here, most people are just doing supervised fine tuning. What they're doing is they're filtering out good trajectories that work really well. They're trying to go focus on data quality, and then they're doing very vanilla fine tuning. So you take the data that you have in this format, and you just pass it into any of the libraries out there that help you do supervised fine tuning, okay? And you can see here that the gains that you get are quite large. So particularly for in-domain tasks. So in the top plot over there is showing in-domain tasks, and you can see that the lift is quite high. Out-of-domain tasks means when you're really trying to do zero-shot tasks where you're not fine-tuning on it. But I would say most people that are fine-tuning their own models for agents are doing it for a specific use case. A second observation here is that bigger models are better, but I would say that's very much a product trade-off. It's cost, latency, a whole bunch of concerns there that you have to think about. So whether you're going to use a big model or a small model, that is very much a kind of a question on the model, the application itself that you have. The one other point I would say here is I'm just talking about supervised fine tuning. There's a million other ways to fine tune things. So if you're doing preference fine tuning for like reinforcement learning with human feedback, you typically have two answers and you say, I know one answer is better than the other. You can do that exact same fine tuning for function calling or for agent trajectories. So there's a lot of different choices to explore here. And actually, I haven't even seen examples of that yet with function calling, surprisingly, in the open source world yet, even though that's kind of an obvious one to try. The final thing I want to say, just in terms of what you could do, is consider embedding within a multi-agent system. So this is not really about fine-tuning, but this is just to give you some more hope. This is a paper that just came out called Mixture of Agents from Together AI. And they show that a mixture of agents, which are these top models here, outperform GPT-4 Omni on these quite comprehensive benchmarks. And a mixture of agents just intuitively is like you ask a lot of different models to answer the question, and then you have sort of an aggregator model that looks at all those answers and says, now you generate an answer. And so if you're not working on an interactive use case, if you're working on an agent that does something like coding, you can actually gain a lot by having multiple agents, ensembles of agents, multiple shots of agents, and you can get a lot of performance on that side. So should you fine-tune agents, just to wrap things up? The con is proprietary models still have a significant lead over open source models for agent use cases. Collecting agent trajectories is quite complicated, and especially for complicated tasks like think about the coding agent. It's not at all obvious how you do that, and you definitely have to build a lot of agent infrastructure to try to collect those tasks. Certainly experts just building out their entire workflow to solve and debug a coding bug is not easy to do. Fine-tuning also, while we do get better performance, can easily degrade general performance and become a game of sort of whack-a-mole. And so you need to kind of scope things are. That's where maybe ensembles of models are potentially beneficial. And then scale effects are very real. and that's just something that you need to be aware of. So you're unlikely to beat, the generalist, the frontier models if you're trying to go for a generalist agent. So definitely don't do that. And then finally, why should you do it? You'll learn a lot. You'll generate a lot of useful data. Self-instruct methods and agent gems are a great way to collect trajectories, and it does make it feasible. You can significantly increase performance within specific domains. So if you have a narrow domain, even a 1 billion parameter model can win. Open source models are getting better. Maybe we'll hear about a new one tomorrow. I don't know. It does allow you to control your destiny, which can be quite exciting if you have a specific use case you want to do that can't be done. So net is, I would say, at the very least, learn how to fine tune a model. It's not that hard, and give it a shot as a first step. Thank you. Happy to kind of go a little bit deeper in with if anybody has a question and they want to come up and chat with me.